Today, we are going to be talking about solving linear equations in an Algebra 1 context. The following is a good breakdown on how our video today is going to walk us through solving linear equations. So let's get into it. Let's start with our first section, properties of equalities, or rather, the review of. These properties are essentially the heart to understanding how to solve linear equations. With many of my students, usually if they are confused somewhere, particularly in the beginning of understanding linear equations, it's because they don't have a full grasp of these properties, which they would have learned years prior and have just not retained it throughout their math classes. So let's go ahead and get started with the first property, the additive property of equality. The additive property states that if we had a true statement, say a statement like 1 is equal to 1, a statement that we would all agree is true, right? 1 is equal to 1. And we were to add a number to both sides of the equal sign. So let's say we add 2 to both sides of the equal sign. So we get 1 plus 2 is equal to 1 plus 2, or 3 is equal to 3, that we maintain truth. And as you can see, when I add the same number to both sides of the equal sign, truth is upheld. This is the additive property of equality. The second property, the subtraction property of equality, is very similar to the additive property. The subtraction property of equality states that if we have another true statement, and let's go ahead and look at something other than 1. Let's look at something like 5 is equal to 5, another true statement. If we subtract the same number from both sides, so let's subtract 2 from both sides. 5 minus 2 is equal to 5 minus 2. Or in other words, 3 is equal to 3, that we will maintain truth. And as you can see, 5 equals 5 is a true statement. By applying the subtractive property equality, we get 3 equals 3, which is also a true statement. Next, we have our multiplication property of equality, which states that if we multiply a number on both sides, that we will maintain truth. So let's go ahead and start with our 1 equals 1. So we have 1 is equal to 1. Let's go ahead and multiply, say, 7 on both sides. 1 times 7 is equal to 1 times 7, or 7 is equal to 7. And as you can see, we maintain a true statement by multiplying a number on both sides. The last property we have is the division property of equality, which states that if we divide the same number on both sides, we get a true statement. So let's go ahead and start with our, let's say 10 is equal to 10, and we're going to divide both sides. We're going to divide both sides by 2, so 10 divided by 2 is equal to 10 divided by 2, and that gives us 5 equals 5. So you can see that we maintain a true statement here as well. Moving on into our next section, it's going to be very important to keep these properties close in mind, since when it comes to solving linear equations, that is literally all we are going to be doing is just applying these properties over and over again in different orders until we've isolated our x variable. Let's look at our first problem. Let's go ahead and have this 2x plus 3 is equal to 9. Now let's just remind ourselves of the goal here. When we're solving a linear equation, we really only have one goal, and that is to isolate our x variable. And the way that we're going to do this is by applying the properties that we've just reviewed. So for those of you who are just starting out in solving linear equations, I like to identify which operations are being conducted against this x, and then doing the inverse of that to separate them, to undo those operations. I.e., I can see that the first operation being done to this x is that I am adding 3. There is an addition operation that is being conducted on this x. That means in order to get rid of the addition, at some point in time, I will have to subtract. Additionally, there is multiplication by this 2 that is being done to this x. So I see that there's a multiplication operation. And that means in order to get rid of that multiplication, at some point in time, I will have to divide. And we are going to do these particular operations on both sides of the equal signs, much like the properties of equality tell us, because when conducting them, all properties of equality will maintain truth. So we'll continue to have a true statement with each step. So let's go ahead and look at our 2x plus 3 is equal to 9. And let's start with the addition. Let's start by getting rid of the addition by conducting the subtraction property of equality. We could start with the multiplication and division, but I think that we end up confusing the problem a little bit more or making it a little bit more difficult for us to solve. I always like to do the addition and subtraction first, and usually ending on the multiplication and division, depending on what the problem looks like. So I'm going to use the subtraction property of equality, and I'm going to subtract 3 on both sides. And I'm choosing to subtract 3. I can subtract any number that I want, but subtracting 3 is the only thing that's going to get rid of this 3 in our equation. And that leaves me with 2x is equal to 6. Now, one thing to note is that I've set this up probably the most common way that it is set up. Your teachers have probably set it up this way as well. But I want to let you know that this isn't some trick to solving linear equations. This is actually just the subtraction property of equality, and we can write it so that way it looks more like that as well. So I can write 2x plus 3 minus 3 is equal to 9 minus 3. And you can see that we're really just subtracting 3 on both sides. And that will give us the same solution that we have prior to this. 2x is equal to 6. Now I'm going to go back and I'm going to use my preferred way of doing it because I think the organization from this way is a lot better and easier to see. So from this step here, I'm going to divide by 2. And I can see that that's the last step that I have is a division of 2. So let's go here and let's divide both sides by 2. And I get x equals 3. And there you have it. We've solved our first linear equation. Now let's go ahead and start on our second problem, keeping in mind that with each new problem, it'll be a little bit more involved for us. So for our second problem, we will have a 2 times x plus 4 divided by 5, which is equal to 2. Let's start like we did our previous problem, and this will be the last time that we do that. Let's identify which operations are being conducted to this x. So first, I can see that I have division with this 5. I have addition with this 4. And I have multiplication with this x. Multiplication with this quantity of x plus 4. What's important to note here is that that means that there's going to be at least 3 operations that I'm going to have to conduct in order to separate this x, namely the inverse of all 3 of these operations. So let's go ahead and get started by getting rid of this 5. I think the easiest way to see that is, or the easiest way to get rid of it rather, is to multiply both sides by 5, the multiplication property of equality. So I'm going to take this 2 times x plus 4 over 5, and I'm going to multiply this by 5. And I'm going to take this 2 and I'm going to multiply this by 5 as well. Well, the commutative property is going to kick in for both of these 5s, and they're actually going to cancel out and become a 1. And that's going to leave us with a 2x plus 4, which is equal to 2 times 5, which is 10. And remember, the multiplication property of equality guarantees truth so long as we're multiplying both sides by the same number. So I know that this is still a true statement, still solving for x. Now, for those of you who may not see why this occurs right here, why they disappear, again, this comes from the commutative property. Let's go ahead and do a little bit of an aside, and we'll look at our commutative property, refresh our memories here, commutative property. And the commutative property states that if I have a number a and I multiply this number by b, this is going to be equal to that same number b times that same number a. Basically, I can swap the order. So to give a really good example of what's occurring here, let's go ahead and take our number 1/2 and let's multiply this by 2 over 1. When I multiply these together, instead of actually just making this 2 over 2, I'm going to just keep the numbers together. It's going to be 1 times 2 over 2 times 1. Now, the commutative property states that I can swap the order of either the numerator or denominator, or both, depending on how I feel. But I'm going to swap the order of just the numerator. And I'm going to rewrite the numerator as 2 times 1 over 2 times 1. Now, because I started with them apart, and I brought them together, that means that once they're together, we can bring them apart. So in doing so, I will actually bring them apart and have 2 divided by 2 times 1 divided by 1. And you'll note 1 divided by 1, well, that's just 1. And 2 divided by 2, well, that's just 1. And we are given 1, which makes a lot of sense because our original problem was, what is half of 2? 1/2 times 2, what is half of 2, which is 1. Here's the same thing that's occurring. I actually have this 1 below this 5, and I'm just swapping the position of the 5 and 1, so I end up with 5 divided by 5, which cancels them out and leaves me with a 1. Now looking back at our equation to finish solving this, I'm going to divide both sides by 2. So let's get our 2x plus 4. Let's divide this by 2. This is equal to 10 divided by 2. So 2 divided by 2, I have this multiplication of 2 and this division of 2, gives me 1. So I'm left with just an x plus 4, which is equal to 10 divided by 2, which is 5. And now I can subtract 4 on both sides, and this gives me x is equal to 1. And for our last problem, let's go ahead and look at problem number 3, which will be 2 times x plus 1 divided by 3 minus 8 is equal to 2. Let's go ahead and start off by adding 8 on both sides so we can get rid of this minus 8. So we get a 2x plus 1 divided by 3 is equal to 10. Now I see, like the previous problem, I have a 3 that's dividing here. So I'm going to multiply both sides by 3. You guys are going to see me set this up a little bit different. I'm actually going to multiply the entire equation by 3 and distribute it in. That's going to give me a 2 times x plus 1, and 3 times 10 is 30. I now have a division here, so I'm going to divide both sides by 2 to get rid of this multiplication here. And that's going to give me a x plus 1 is equal to 15. And then I'm going to subtract 1 on both sides and get x is equal to 14. Let's go ahead and move into a few problems for you to try on your own. So on this next section, go ahead and just pause the video once you see the problems and give them a shot. And welcome back. I hope those problems didn't give you too much trouble, but let's go ahead and look at the solutions a little bit here. Starting with problem 1, we have 4 times the quantity of 3x minus 1 is equal to 32. We're going to start off by dividing by 4, and then we should be left with a 3x minus 1 is equal to 8. We're then going to add 1 onto both sides, so we get 3x equals 9. And then we're going to divide both sides by 3, and so we should get our solution, x equals 3. For our second problem, we have the quantity x plus 2 divided by 4 is equal to 1. We're going to start this problem by multiplying both sides by 4. That leaves us with x plus 2 is equal to 4. We're then going to subtract 2 on both sides, and that leaves us with our solution, x is equal to 2. And finally, our last problem, where we have 3 times the quantity of x plus 2 divided by 2 plus 3 is equal to 12. We're going to start out by subtracting 3 on both sides to get rid of this plus 3, and we're left with 3 times the quantity of x plus 2 divided by 2, which is equal to 9. We're going to multiply both sides by 2, and that gives us a 3 times x plus 2, which is equal to 18. We're going to divide both sides by 3 because it's going to be a lot more efficient than distributing first. And that's going to give us x plus 2 is equal to 6. And then we're going to subtract 2 on both sides, which gives us an x equals 4 for our solution. Moving into our third section, which is just discussion-based answers. It's going to be important for you to not have to write anything down. Really, as the problems come up, I want you to just pause the video and do your best to say out loud, explain back to me what the next step would be in the problem. Starting with our first discussion, go ahead and pause the video now. And without writing anything down, see if you can explain to me exactly all of the steps required to solve the problem. Now, if your first recommendation here was to add the 6, that is exactly how I would start this problem, so I think that is a very appropriate way. You also could have suggested to divide by -4 first. I don't think that's where you would have wanted to end up. I think that would have been a little bit more confusing to do the problem. Still a valid way, though. And this would leave us with a -4x is equal to 8. And then if you then suggested to divide both sides by -4 to get x is equal to -2, you would have explained how to solve this problem exactly right. And moving to our last discussion, go ahead and pause the video again here, same rules as last. See if you can explain out loud all the steps that it would take in order to solve this problem. Now, there's actually two ways that we could go about solving this problem, and either suggestion would be correct. For those of you who are like me and don't like fractions, we would start by multiplication first. And for those of you who don't mind fractions, you probably would have started with subtraction first. Let's go ahead and look at what both ways of solving would be. So for the multiplication first, that would be taking our entire equation, this 1/2 x plus 2 equals 1, and multiplying everything by 2. And that would give us a x plus 4 equals 2. And then subtracting 4 on both sides, so x is equal to -2. For the subtraction first, that would involve us taking this plus 2 and subtracting it on both sides. And that gives me a 1/2 x, which is equal to -1, and then multiplying our entire equation by 2 to get rid of this 1/2. And that would leave us with x is equal to -2. And you can see that both ways will give us the same solution. And for our final section, we will be moving into error analysis. For this section, I'm going to be solving a problem in front of you. However, I'm going to be making a mistake. And what I'm going to be looking for you is to identify where that mistake is, and once found, go ahead and correct the mistake and see what the solution would have been. For this problem, let's go ahead and look at 8 is equal to -2 times x minus 3. I'm going to start with distribution, and I'm going to multiply this -2 into our quantity x minus 3. And that's going to give us 8 is equal to a -2x minus 6. I'm then going to add 6 to both sides, so I get 14 is equal to -2x, and then I'm going to finish the problem by dividing by -2. So for my solution, I get x is equal to -7. However, this is incorrect. Somewhere along the path, I have made an error. Can you spot where it is? Well, for those of you who've got a very sharp eye, you would have seen that I actually distributed wrong. When I multiplied in this -2 and I multiplied it against this -3, I should have had a +6, not a -6, because if we recall, a negative times a negative is equal to a positive. So if we were to solve this problem correctly, we should have 8 is equal to a -2 times x minus 3. If I distribute in the -2, I should get 8 is equal to a -2x plus 6. I then would be subtracting 6 on both sides, which gives me 2 is equal to a -2x. Divide by -2, and I get x is equal to -1. So this should have been my solution. I hope that was a fair bit of fun for you, and I hope you took something away from these lessons. Again, if there's any confusions about anything in the video, feel free to leave a comment below, and I will message back as soon as possible. Until next time, this is Hierarchy Education.